Hi, and welcome to the tutorial for the Quick Area Calculator. This tool is available on DAM right here under Time Savers, but you probably already know that because you're watching this video. So once you download everything and open it up, it will probably not look like this. And that's because the first thing you're going to need to do is pull up Grasshopper. Let's move this out of the way. This tool is built on a plugin called Human UI, which should be installed on your machine already. But Human UI, there's a little trick to get it to work in Rhino 6. You got to go File, Preferences, go down here to Solver, and then scrub all the way down to Human UI and click this until it turns orange. And then close Rhino and Grasshopper, open it up, do it again and make sure it's still orange. You might need to even restart your entire computer. I hope you won't. But you need to do that in order for Human UI to work. But once you've done that, you should be able to open this Rhino file, open the Grasshopper script, and this window should pop up, and you will basically be off to the races. So what this tool does is it allows you to model a wide range of objects and geometric forms very quickly. So in a master plan, for instance, and it will very quickly calculate the current area in your model and compare it to a target area. If you are modeling every floor in your master plan by hand, God bless, that's courageous. That is the best way to get 100% accuracy. This tool is built for speed. It's going to calculate the volume in each object and then divide that volume by the floor-to-floor height in your building. So that is super accurate for boxy shapes that are modeled accurately. It will have some errors as you get into like really expressive, sort of aggressive tapered shapes, or if you make a building that's a giant sphere. But that accuracy should still be, within 5% or so of any realistic geometry. So this tool is meant to help you model quickly. It is not a replacement for doing a final sort of rigorous area check before any major deadlines, before you send the model out to get built, or the the images to the renderers. So with that in mind, the way the tool works is it's linked to a spreadsheet like this, where you specify all of your layer names, you specify your target areas in either meters or feet, and you specify your floor-to-floor heights in meters or feet. You can model in millimeters, and it will assume that your areas and your floor-to-floor heights are in meters. Similarly, you can model in inches, and it will assume that these numbers are in feet. You cannot model in inches and give it gross area targets that are in meters, because that would be insane. So once you have your file set up, and I would encourage you to follow along using this example file, but once you have your own model, the first thing you'll need to do is link this script to your Excel sheet that is germane to your particular project. And you'll do that. All of the controls that you need are up here. These are the inputs, and you can ignore the rest of this script. And that's because there's a bunch of scary stuff down here, but you don't need to know what it does. You don't need to care about it. So here, this is the path that you set to your Excel sheet. If you right-click, you can set one path, and you just go and click on your spreadsheet, and that's it. Once you have that path set, you probably don't need to do anything in Grasshopper. You can, if you want, use these controls to modify the width and the height of your area visualizer, but you don't have to. If by accident you close the window and you need to get it back, you can toggle this. And the only other thing you could possibly want to do in Grasshopper, it's a pretty quick tool, but for instance, if I delete this guy here, you'll notice this updates right away. and it updates quickly, but it does take a second or a couple seconds. And that's going to be pretty annoying if you're doing a lot of modeling. You're not going to want to have this script running while you're doing that modeling. So if you go to your Grasshopper window and you center mouse button, you can click on this little lock, and that means you've locked the solver. So now Grasshopper is not going to recompute, and you can delete things, and you can scale things, and you can, whatever, copy things, do whatever you want, and then you can unlock the solver, and all of this will recalculate, right? And that's really the only thing you need to do in Grasshopper. So we can unlock that. So you can take that, you can just minimize your Grasshopper window and get it out of the way. And everything else you do with this tool, you just do it in Rhino. You've got your little window here, and you've got your spreadsheet. So the spreadsheet that we already went through, if you want to make changes to that spreadsheet, like let's say our resi target here, clearly we've got a lot more residential area than our target. Let's say we want to update that target. Let's put this at 600,000. If you save that spreadsheet and we go back to Rhino and Grasshopper, this hasn't updated automatically. If you want to update from the spreadsheet, you click this button, Update from XLS. And now you'll see that target has changed. Similarly, you can change anything you need, the floor-to-floor heights, you can change the name of the programs, you can add more programs, add as many as you want. Just make sure that every program has a target and a floor-to-floor height, and you'll be all set. If you want to take this data and export it to the spreadsheet so that you have your areas, just click Export to XLS. Now this works most of the time. Sometimes it can be a little buggy. So for instance, right here, it did not export. We can try it one more time. And if it still doesn't work, just close the spreadsheet and try it. Okay, there it is. Sometimes you just got to click it a couple times. There's a lot going on in that Grasshopper script. You can also just close the XLS, click export, and then reopen it, and it should be there. If it's not, let us know. We'll help you out. But it shouldn't be too much of a problem. Okay, so the spreadsheet gives you the names of the layers that Rhino is going to look for to read into this calculator, right? So you need to have layers in Rhino that match exactly the layer names in your spreadsheet. It's case sensitive. It doesn't matter if the layer is a parent layer like this or a child layer like this under some other layer, but you can't have duplicate layer names. So if you want to have multiple schemes in your model, and you put Resi Hotel and Office under Scheme 1, and then you put Resi Hotel and Office under Scheme 2, that's going to break this script. And we'll go over the warnings in a minute. The script is smart enough to tell you that you're doing something it doesn't like. But the goal is to really just have unique layer names. And so if you want to have multiple models or multiple schemes in your model, I would recommend that you use layer names like Resi 1, Retail 1, Office 1, and have multiple Excel sheets. And then you can just change the path as you sort of validate each scheme. Let's see, what else? The colors, you'll notice Rhino is going to read, or rather Grasshopper is going to read the colors from your Rhino file. So if you change those, this will update automatically. The units, I already mentioned in the Excel sheet that you really only want to model in meters, millimeters, inches, or feet. If you're modeling in kilometers or microns, you're fired. I have terrible news for you. You've been fired. You can't work at KPF anymore. The script is smart enough to recognize that you're modeling in some totally bizarre units, and it will break and tell you to fix it. But the script is also smart enough, as I mentioned, nobody tracks areas in square millimeters. So if you are modeling in millimeters, it will give you calculations in meters. So it's a reasonably smart tool. So let's talk a little bit about the errors. There are two types of errors that this tool is designed to handle. Also, so in these charts here, you can always, if your areas look good and you just want to address your warnings, you can minimize these little windows. There's also, we didn't go over the floors. So right now, it's going to be much faster if you just let the tool calculate the volumes and return the areas. But if you want it to draw floors, you can turn it on. And you just see you have to wait a little while because now it's going to section everything in the model, and that's going to take a little bit of time. But it will draw floors for you. You can also bake those floors by clicking here. And what that will do is it will create a layer here called floors, and it will bake all of those floors to that layer. And you can see it takes a little while, right? So you gotta be patient. But then you'll get everything here that you can visualize, or you can make 2D, or you can do whatever you want. So I'm just undoing. So we'll just give it a moment. But yeah, there are two main types of errors. Let's just turn these off. There are what's called critical errors, which will break the script, and you will see warnings down here that will instruct you as to what that error is. And then there are warnings, and warnings will lead to some inaccuracy in the modeling, but they won't necessarily break the script. And so it'll be up to you, the designer, whether the sort of speed of modeling in your workflow is more important, or whether you want to fix those errors. So let's go over some of the critical errors. For one, if you don't have your path set, right? So if I go here and I clear this, the script has no Excel sheet to read, right? So it doesn't know what areas to read in. So it'll tell you here. And it even tells you it's the bright green component at the top of the Grasshopper script. So that's handy. You can set this guy, come back here, you'll be all set. If you have multiple layers, so I mentioned before how you can have either parent layers or child layers. If you make the mistake that I warned you about earlier, where you've modeled like 2 layers named Resi, the script will break. Because what happened in previous versions of this tool was exactly what I described. People had multiple versions of their design, so they had multiple layers named Resi. So the script was reading in geometry from both layers and giving extremely inaccurate results. So to address that, down here, let's hide this. Critical error must be addressed before calculation can continue. Multiple layers with same name. So we can fix that by deleting that layer. The next type of critical error is the units, which I already mentioned. If you are modeling in kilometers or miles, or God help you, whatever other units you're using, you'll get a similar error. It will recognize that it doesn't know how to convert those units, and it will tell you. The script will break. The reason it breaks is so that you don't, by accident, go with the numbers that it's giving you. In that case, we thought it was a lot safer to just have the tool return nothing at all. You can have a layer like education that doesn't have any geometry on it, because we think like it's certainly possible that you're going to model a whole bunch of, or you're going to specify a whole bunch of layers, but you might not have modeled them yet. But you cannot do the inverse. If you have listed programs that you intend to model, but you haven't even created those layers yet, the script will break. And the reason for that is if you have a really complex stacking chart with lots of amenities and phasing and all, 10, 20 different types of program, it's pretty easy to miss one of them, and we don't want you to do that. So the script will break until at the very least you've created all of your layers, and that way they'll all be represented in the chart. And the last type of error is if you're missing some data here. So if I delete office, for instance, or if you left out one of your floor-to-floor heights, something like that. If you update the XLS, update from XLS, the script will break. And so that's just a way of sort of forcing you to make sure that everything's as it should be. So the warnings are, as I mentioned, a little bit more optional, right? So again, I'm recording this tutorial from my laptop, so I apologize for the small screen because that can make it a little hard to see things. Warnings, when you open the script, this button here will be in the default on position, and the warnings are both visualized in the script by the geometry, or in the model by the geometry that turns red, and then the warnings here will be spelled out for you as well. And there are a number, and I have tried to include them in the model so that you can see what's going on here. So meshes. Meshes are not included in the area calculation. And that's because typically the meshes that we've seen in the models, people at KPF don't tend to model in meshes. The meshes are usually read in from some sort of site model or existing context. They can be super complicated, and they can cause very inaccurate area calculations. So meshes will not be included in the area calculation. If you delete the offending geometry, that warning goes away, right? So these warnings are only the errors that you currently have in your model. Open geometry will create inaccurate areas. So if you have this little sandbox here, because we're calculating the volume, and then we are estimating the area in the model based on that volume, open geometry has no inside and outside, and therefore has no volume. So that will cause an error. Likewise, overlapping geometry here, because you have two pieces of geometry, if you have, it could be a bump out, it could be a cantilever, it could be, God only knows, see it all the time. We model really quickly when we're in a rush for a deadline, and you're just smashing a bunch of geometry together, but the script is calculating the volume for each of these objects. It doesn't know that they're overlapping, and therefore, that area, and we can do a more extreme example, is being double counted. And so you may just say that you don't have time to fix it, and that's fine. This might be a relatively small error in the context of your master plan, but that's up to you to decide whether or not you want to resolve it. You definitely do not want an area calculating script that attempts to Boolean all of your geometry for you, because that's going to be a nightmare, it's going to take forever, and it's almost guaranteed to break all the time. So we're not doing that, we're just telling you where the problem is. Lastly, this is an interesting case. This is sort of an improvement on the previous version of this tool. So previously, if you had bad geometry, this looks like a good piece of geometry. But if you zoom in, oh my God, what is that? I don't know. I didn't model it. I took it from an actual KPF master plan. Weird things happen when you're working on a China project at 3 o'clock in the morning. And we understand, and we have built this tool to accommodate you. So bad geometry is okay as long as it's closed. But the last thing is this one here, buildings not divisible by floor-to-floor height. And we can turn on draw floors here. And we put this one in dark red so that this is a fairly easy thing to address. So we made it a slightly different color so that you could pull it out and go and address that specifically. But basically what we're doing here, right, is we're dividing the volume by the floor-to-floor height, which works great assuming that your building is divisible into an equal number of floors. But if you've got like a tiny little sort of half floor at the top of your building, that's probably not actually a floor, right? That's probably like a mechanical floor, or it's something that's supposed to be larger, and it's not supposed to be counted. So this script is assuming that you're going to model something nice and neat, like this resi here, which we can't see, is 35 meters, which divides nice and cleanly by our 5-meter floor height for resi. So if you have sloppy modeling, You got to fix it if you want accurate areas. Typically at a master plan scale, people do not model mechanical floors and double height atria and things like that. So be aware that's how the tool is working. Once you know that there are a few errors in your model and you say, guys, I just let me model the thing and stop making my model red. It's driving me crazy. You can turn this off. The warnings will still be down here, but you can also hide those and just turn on your chart. I think that's it. It's a lot of information, but really, once you're in the model, it's super easy to use because you don't have to do anything in Grasshopper. You can just scale things and everything should be pretty automated. It should be a pretty easy tool to use. Definitely give us feedback if you're finding that this tool is doing things that you didn't expect, it's breaking in weird ways, or you think you're fixing the errors, but they're not going away. Just let us know. We'd be happy to incorporate your feedback into the next version of this tool. The tool will probably get much, much better because you took the time to let us know what you thought about it. So thanks, and we'll talk to you soon.